Hello everyone, myself Mohammed Shafiullah, Assistant Professor in Department of CSC, BITM Ballari. Welcome back to this course on C Programming for Problem Solving. In this session, I am going to explain you selection sort program. So the problem here is to develop a program to sort the given set of n numbers using selection sort technique. So sorting is basically a process of rearranging an array or a list of elements according to a comparison operator. So sorting is that process which involves arranging the data into some meaningful order wherein we can easily understand this or analyze it. Bubble sort, merge sort, selection sort are few examples of sorting techniques. Coming to selection sort, it's a simple sorting algorithm. This algorithm sorts an array by repeatedly it finds the minimum element. If you are trying to arrange the elements in the ascending order, this selection sort algorithm repeatedly tries to find the minimum element from the unsorted array and tries to put that at the beginning part of the array. Remember, this algorithm is an in-place comparison based algorithm wherein the list or the array given to us will be divided into two parts or two sublists or two subarrays, into two parts or two subarrays. The first one is the sorted part which we will have at the left hand, and the next is the unsorted part which will be at the right hand. So there will be two subarrays or two parts. One is the sorted part which will be at the left side, other will be unsorted which will be at the right side. Initially when we start our sorting process, the sorted part will be empty and the unsorted part itself is the entire array. So the smallest element is selected from the unsorted array and will be swapped with the leftmost element. In the first iteration or the first case, the smallest element is selected from the unsorted array and that will be put at the leftmost side. That is, where do we have the sorted part? We will have at the left side. So there we will put the smallest element at the leftmost, and that itself becomes our sorted array, part of the sorted array. And in every iteration of selection sort, we will get the minimum element from the unsorted subarray and then try to move it to the sorted subarray. This process will continue until all the elements are sorted in ascending order in the array. So these are the steps which we have in selection sort. Try to set the first element as minimum. To begin our sorting, we need to assume that the first element as minimum. Then compare this minimum with the second element. If the second element is smaller than the minimum, assign this second element itself as minimum. Then compare your minimum which we had assigned to second element, right? Compare this minimum with the third element. Again, if you realize that the third element is smaller than the assigned minimum, then what you have to do, if the third element is smaller, then assign the minimum to third element. In case if the third element is smaller, you try to assign that third element itself as minimum. Otherwise, don't do anything. So this process goes on until you reach the last element. What is your step 3? After every iteration, minimum will be placed in the front of the unsorted list. After each iteration, minimum is placed in front of the unsorted list. So for each iteration, indexing starts from the first unsorted element. Step 1, 2, 3. This for each iteration where we start the indexing from the first unsorted element. Okay. So now step 1, 2, 3 are repeated. How long? Until all the elements are placed at their correct positions. So let us consider an array of integers to understand this, and we have to sort them in ascending order. The input is an array of 6 integers, 10, 12, 5, 14, 9 and 7. We have to sort this in using selection sort. We have to sort this in ascending order. Can you tell what will be the output of this? Of course it should be 5, 9, 7, 9, 10, 12, 14. 5, 7, 9, 10, 12, 14, right? So what are the variables we use in this program? Array A, I, J, N, temp and min. Now this is our given array. What is the procedure is? First you assign the minimum as the first element for the first position, right? We assume this. Now what we have to do for this first position, we will try to find the minimum. So the whole array scans sequentially. What we have to do? Where is our first element? 10. Here 10 is present, right? To get this, initially we have this unsorted array. We don't have the concept of, now we have sorted array but it is empty. The entire list is unsorted array. So what we will do now, compare 10 with 12. We set minimum as 10. Whether 10 is small, 12 is smaller than 10? No, right? 10 is smaller than 5? Yes. So assign this to as minimum. Then again compare 5 with 14, 5 with 9, 5 with 7. Fortunately, we have 5 itself as our minimum. So what we will do? Replace 10 with 5. So I'll repeat it. First we will, for the first position wherein we have 10, right? So what we have to do? We have to find the minimum element among this. So which is our minimum element? It is 5. So what we will do? We will swap this 10 and 5. Why are we swapping this 10 and 5? Because it is a direct swap between the smallest element and the first element. So which is our smallest element? 5. Swap it. So 5, 12, 10, 14, 9 and 7. Look at the colors here. The orange one indicates that the sorted array. The the yellow in color indicates that that particular element is being swapped now. So now for the second position, so now we can say that 5, we have only one element in the sorted array. The remaining is the unsorted array. For the second position wherein we have 12, what we have to do? Start scanning the rest of the list. So now if we look at it, 12, 10, 14, 9, 7, if we repeat the same process, we realize that 7 is the smallest among the remaining. So what we have to do? A direct swap between 7 and 12. But it is not going to happen directly, it is going to happen one after the other sequentially. So 5, 12 and 7 are swapped. Look at this, after 2 iterations, 5, 7, 10, 14, 9, 12. So where do we have 12 here? This is a swap. So now this is our sorted array. 10, 14, 9, 7, 12 is left. So now for the third position, for this 10, if we check it out, 10 with 14, 10 with 9, 10 with 12, we have 9 to be the smallest. So swap it. So we have 9 and 10 to be swapped. So now this is our sorted array. The orange color 5, 7, 9 is the sorted array. The remaining is the unsorted array. So now this process is applied on the remaining elements. How long? Until all the elements are sorted. So how it appears now? For 14, 10, 12. You compare 14 with the 10. 10 is smallest, right, among this. So swap 10, 14, 12. Now 12 is again sorted, right? What we have left now? We have now 14. So 14 is added to the list. So this is how it goes. So finally the output array after sorting is 5, 7, 9, 10, 12 and 14. So this is the program to sort the numbers in ascending order using selection and sort technique. We have header files, then we have main function. In main function, this is our local declaration section. So these are our variables used. And as usual, we have seen in arrays programs, this is to enter the size of the array that we are going to store it in a variable n. And this is the code which inserts the elements into the array, right? So this is a printf statement, enter the elements of the array. Then we are starting our index from 1. For I equals to 1, I less than or equals to n, I plus plus, scanf %d ampersand a of n. So till here it is about insertion. The same elements we will try to display it before we sort them. So this is the code to display the elements of array before sorting, right? Instead of scanf, we have here printf %d/t. Same thing, we have a printf here to enter. Here it's to elements before sorting, unsorted elements. So now this is the actual logic which is going to sort the numbers using selection sort technique. So this is the code which sorts the numbers in ascending order. So this is our for loop. We have a series of loops, nested for loop. For I equals to 1, I less than or equals to n minus 1. Same thing, n minus 1, I plus plus. Now this is our for loop which begins here. Now min equals to I. We assume the first position as the minimum, the first element as the minimum element. So we try to assign that position to minimum. Min equals to I. So after this, now we will compare this minimum element, the first element, with all the other elements of the array. So that is why we are taking for j equals to I plus 1. The value of I is 1. What is the value of j? 1 plus 1, 2. So now we will compare our a of min. What is our a of min? A of 1 with a of 2. J value is 2, right? If a of 1 is greater than a of 2, if a of 1 is greater than a of 2, what we will do? We will take min equals to j, because we have found an element smaller than the first element. So what we will do? We will not swap, we will have to just take that position. That's it. It's not a of min equals to a of j. Please understand here, it is not a of min equals to a of j. It is just we are taking the position, the location. Suppose if I go with my example, what is my example here? Here I had the first element as 10. So what I will do, if I find 10 is greater than 5, right? 10 is greater than 5. If 10 is greater than 5, 1, 2, 3. So what is the position of 10? 1, 2, 3. So what I will do, I will assign minimum as 3. It was 1, now I will assign minimum as 3. What I will do again, after this again I will increment my j value. Again I will do with this third value, fourth value, so on. So basically this part of the code is to find the minimum location. In each iteration it finds the minimum. So once it is done, what we have to do, you have to swap, right? You have to swap the minimum element and the assign, you have to swap the first element with the minimum element in the first iteration. So that care is taken here. So this code basically will swap temp equals to a of I equals to a of min equals to temp. So after first iteration, that is after one iteration, after swapping it goes back. So after first iteration, this is what we had achieved, right? We got this case 5, 12, 10, 14, 9, 7. So we have got this sorted array. Now what we have to do, I value should become 2, right? This is 1, so I value becomes 2. So I value will be 2. So now we will assume minimum as what? 2 but not 1. Why? Because what is our second element? Where is our second element? It is at 12, right? We will take this as 2. So we will take the location min as 2. Now start with third element. Compare second with third. So what is your second element? 12. 12 with third. Whether 12 is greater than 10? Absolutely right. 12 is greater than 10. So change your min from 12 from 2 to 3. Your min is 3. That is what we are doing here. So our min will be 3, but again j will update. After updation, finally once we reach the end, our min will be 1, 2, 3, 4, 5. It should be 5. Our min will be 5. Sorry, it will be 6. I'm sorry, min will be 6. Why it will be 6? Because here is our smallest element. So min will be 6. So once the value of min is 6, what we have to do? Swap here again. So we will swap. So this code, this swapping is done. Once it is done, we get this 5, 7, 10, 14, 9, 12. This swap actually, this was a swap to swap this 7 and 12. This is how it goes. So when I value becomes 3, we do this, right? So basically, let me tell you this again. So here I have a for loop wherein in each iteration what I have to do, initially assume the first element itself as the minimum. Then in each try to find is there any other element which is smaller than this minimum. If that is the case, try to assign the location of that. Once you compare with all the elements, what you have to do, swap the first element and the assigned minimum at the smallest element for every iteration. So this is how it happens. So here is this inner for loop ends. You have this j, right? This is going to end here. So this outer for loop ends here. So this outer for loop runs how many number of times? Until all the elements are sorted. But in each iteration, we have to find the smallest element, right? This does this job. Jth loop does the job in each iteration to get the smallest element. Jth loop does the job of getting the smallest element in each iteration. This if condition is going to swap the smallest element, the minimum element, the smallest element with the smallest element with the assigned minimum element. So finally, after doing this, we have to display the elements after sorting. So this is what the code is to sort. So it's to print. So I have the same code here in my editor. Let me run this. This is my selection sort program. So same code I have it here. Let me run the code. Once I run this, so this is asking me the size of the array. I give it as 5. Then I give the elements 9, 0, 8, 5, 43. So now I get this as 9085 is my entered order, 0589 43 is my sorted order. So that's it for this session. Please do comment if you have any doubt in the comment section. Thank you.